In the second half of Chapter 3, we start to bring the coordinate plane back. The coordinate plane we saw in Chapter 1 with the slope and distance formulas, and now we're going to look at slope. Slope is something that you played around with in Algebra 1, but it's been a while, so we want to do a bit of review before we need to use slope in geometry. So if you recall, slope is a number that on the line represents one of four flavors. From left to right, if my line is going up, like my first example here, that is a positive slope. There is a positive number that represents the slope of that line as it goes up from left to right. Well, if my line goes down, like the second picture here, if my line goes down, then a negative number represents that slope. Those are the two cases we see the most often. However, there are two other flavors of slope, and these ones get confused very often. Note in the third picture, that line doesn't go up or down. It doesn't rise or fall. It stays the same. It's horizontal. That is a zero slope. And what we mean by that is the number 0 represents the change in that line, because it doesn't change. The last one is an undefined slope. That straight up and down line is undefined. We will look at examples comparing and contrasting 0 and undefined because students do get those confused fairly often. So in the next video, I will just compare the 0 and the undefined. Let's look at the positive and negative cases first, because they're the ones that usually click pretty quickly. Especially since Algebra 1, you guys did a whole lot of slope stuff. So a quick review on those. In the first two examples here, we actually have coordinate planes, which is nice. Most students remember slope as rise over run. And what we mean by that is we're counting the difference, in this case we're just counting squares, we're counting the difference in the y values, that's the rise, and then the difference in the x values, that's the run. So if I look at my first graph, that rise, I'm just counting boxes here, 1, 2, 3, 4. We rose 4 units. To get the run, my x values, now we're going to the right. 1, 2, 3, 4, 5. So I rose 4 units, and I ran 5 units. Now we typically use the letter m to represent slope. So the slope of that line is 4/5. Note that from left to right, this line does go up. So we are expecting a positive slope. We did get a positive slope. 4/5 is a positive number. Let's take a look at number 2. From point P down to point Q. Now my line is falling from left to right. It's going down. So I'm expecting a negative number. And note that if I go from P, I start at P here, I have to go down 1, 2, 3 units. And then I have to go to the right 1, 2, 3, 4, 5, 6. So I went down 3, that's a negative value, negative 3 over 6. Now that's a fraction that can be reduced. 3 and 6 are both divisible by 3, so I can reduce that fraction to negative 1/2. So note in that second example, we have a negative slope, a line that is going down. And when I did rise over run, I did find a negative number. Negative 1/2 is a negative number. So that checks out. If you don't get a picture like we have in 1 and 2, there is a slope formula. So if you look at that slope formula, it's the difference or a subtraction, the difference in the y values over the difference in the x values, which is exactly what you do when you count boxes. You're counting the change between one point and another point. So the formula is helpful for when you don't have that picture and you don't really feel like graphing and counting boxes. So one thing I always recommend is to take a second and label your points. My points have been pre-labeled for me. You will want to write those down whenever you're dealing with points. The first point I've just labeled x1, y1. The second point I've labeled x2, y2. We did the same thing when looking at distance formula and midpoint formula. So the same labeling will be useful here. The reason we label our points is it makes the substitution step really easy. So if I'm looking at my slope formula, I need y2. Well, I've already labeled y2. y2 is -1. And then I need to subtract off y1. I've already labeled y1. y1 is 5. So I have y2 minus y1. From there, I need x2, which is the value 6. And then I'm subtracting off x1, which is -2. So labeling your points makes it quick and easy to substitute values into the function. I really strongly recommend taking the extra second to write those labels. So in the numerator, I have -1 minus 5, which is -6. In the denominator, we have 6 minus a -2. Minus a negative is the same as plus. So 6 plus 2 is going to be 8. That's a fraction that can be reduced because both 6 and 8 are even numbers. So if I reduce this fraction by 2, in other words, I divide 6 by 2 and I divide 8 by 2, we will get -3 over 4. And that's going to be our slope. Taking a look at one last example, find the slope of GH. Again, I have already labeled these points. I recommend you do the same. So I get a y2 value of 7. I'm subtracting from that a -3. And again, where that -3 is coming from, that's my y1 value. In the denominator, we get x2, which is -6. And we are subtracting off -11. So there's my slope formula set up for me. In the numerator, we have 7 minus a -3. Minus a negative is the same as positive, which is addition. 7 plus 3 is 10. In the denominator, we get -6 minus a -11, so then it'll happen again. -6 plus 11 will be 5. Now, 10/5 is a fraction that we can reduce because both 10 and 5 are divisible by 5. Or you might recognize 10 over 5 is just a division math fact. 10 divided by 5 is 2. So our slope for this bottom line is going to be 2. So hopefully slope formula is coming back to you here. These are our positive and negative examples. They are the most common ones. I'm going to go ahead and put 0 and undefined slope in their own separate video. So I'll see you soon.